Alright, so let's continue with the subtopic trigonometric equations. So for trigonometric equations, right, there are a few steps that you need to know in order for you to solve the trigonometric equations. So I already mentioned about this, but let's just revise again. So the steps involved is, the first step, we need to look for the basic angle. You have to look for the basic angle, and for this one you have to ignore the negative sign. The negative sign, it's just the indicator for us to choose which quadrant is it. Okay, I'm gonna explain about this later on. And the second step, we will sketch out the quadrant. And we are going to decide based on the positive or negative sign. So you know that in the first quadrant, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. In the first quadrant, all trigonometric ratios are positive, and the second quadrant, all signs are positive, and the third quadrant, all cos is positive, and the last one is tangent will be positive in the third quadrant, and cos will be positive in the fourth quadrant. So we are going to determine which quadrant to choose based on a negative sign or positive sign given by the question on the second step. So we are going to decide which quadrant to choose based on plus minus sign. And the third one, we are going to find a new range, because sometimes the question gives us in terms of 2 theta or 3 theta, so we need to be careful with the range given by the question, or domain lah. I mean, the range given is, we need to follow the question lah, because for example, like cos theta, right, equals to 1/2. So in general, you know that cos theta, it's a periodical function, right? So if I were to sketch out cos theta, it will look something like this without a given range. So it will look something like this, and it will goes on forever. It goes on forever, which means that the cos theta, the function of cos theta that is equals to half, there's like a lot of solutions for it. Like it's infinite solutions, because the function keep on going. If you don't set a limit for the range, for example, like from 0 until 360, then there will be only a few solutions that satisfy the equation. So we need to set a range. So that's the meaning of new range. So sometimes it's in terms of 2 theta, sometimes it's 3 theta, and we need to modify the new range according to the question given. Okay, and the next one, which is the last step, you can basically just solve for the answers. After determining the new range, solve for answers. Alright, so for example, I'll just take a very simple example. So solve the equation of cos 2x equals to 0.4630 for the range of 0 degree to 360 degree. Okay, so the first step is to look for the basic angle, and we're going to ignore the negative sign. So first step is to look for the basic angle. Basic angle means you need to make sure that in front of the trigo here, there will be no number, there will be no constant. If there's a constant there, for example like 2, you need to move it over there and divide by 2. Basically, we're just trying to get rid of any constants in front of the trigo lah. Okay, so with this we can start our first step, which is to look for basic angle. The basic angle means we are going to do inverse cosine because we are trying to look for 2x now. So 2x equals to cos inverse 0.4630. Okay, so with this you can just evaluate using a calculator. So shift cos 0.4630, you should get, okay, I should write it as basic angle because it's not 2x. Basic angle cos inverse 0.4630, so the answer is 62.42 degree. 62.42 degree. And the second step is to sketch out the quadrant. So we are going to determine which quadrant is it. So we know that this is positive. This is positive, right? If it's positive for cosine, we will be choosing the first quadrant because first quadrant is all trigo positive. And we'll be choosing cos, which is in the quadrant 4, because we want cos positive. So we will be choosing quadrant 1 and quadrant 4. So we're going to sketch out and we are going to draw the reference angle. And note that the reference angle always attached to the horizontal axis. So here is where our 62.42 is, and here also. Okay, meaning that we are going to take this value, this is our first answer, first solution, and the second solution we will go all the way like this, and we're going to stop here. So how much is this? We know that one circle is 360, so 360 minus of 62.42, so that's our solution for 2x. And hence we have to determine our new range. Our new range, because we are using 2x, and the range given is x, so we need to multiply by 2. So the third step, new range. New range means multiply by 2. So this is the original range given by the question. We multiply by 2, we get 2x and 720. We multiply by 2 for the whole inequality, for the whole range. So we will get this. And according to this, we can take more value in. Because you see, now the range is given by from 0 to 720. That means we can rotate 2 rounds. We can rotate 2 rounds, the range increase. So our first solution that satisfies the range is 62.42. The second one is this 360, which is one circle, minus of the 62.42. That's our second solution. The third solution, we can actually go from here all the way and further on to touch this. This would be one circle, which is 360, plus additional of 62.42. And the last one is go another circle and all the way to here. So we know that 2 circle will be 720 minus of 62.42. So that's our fourth solution. So 2x equals to, the first one is 62.42. The second one is 360 minus of 62.42. Another one is 360 plus 62.42. And we also have 720 minus 62.42. So let's simplify. 2x equals to 62.42, and 360 minus 62.42 is 297. .58, and 360 plus 62.42 will be 422.42 degrees, and the last one, which is 720 minus 62.42, will give you 657.58 degree. So what we're trying to find is x, so we need to divide by 2 for everything because this is in terms of 2x. We want x, so we're going to divide by 2 for the solutions. So we should get 31.2 degree, 148.8 degree, 211.2 degree, and 328.8 degree. So this is the solution for the cos 2x equals to 0.4630. Okay, so the first step, okay, look for the basic angle. Look for the basic angle by doing finding the cos inverse of this value. Okay, and if there's negative sign, just ignore it, because the negative sign just telling us which quadrant to choose. If it's negative here, instead of choosing A, which is quadrant 1, for means that all trigo is positive, and instead of choosing cos, which means cos positive, in quadrant 4, we are going to choose these two instead, because these two, quadrant 2 and quadrant 3, is where cos will be negative. So the negative sign is just an indicator for us to choose which quadrant. So in this case, it's positive, so we are going to choose quadrant 1 and quadrant 4 because that's where cos will be positive. All positive, cos positive. And yeah, sketch out the quadrant and put the reference angle. This is the basic angle. Basic angle is the reference angle basically. And the new range. So we need to set a new range according to the question. So we have 2x. So we're going to set a new range, which is 2x. And we find out all the solution for 2x. And then in the end, we're going to divide by 2 to look for x. So these are our solutions for this question. And let's look at another one. Example 1.63. This is, I think I'll choose question B. Sine x minus 80 degree equals to negative 0.1124. So question asks us to solve this equation for the range of 0 to 360 also. Okay, so as usual, we're going to look for the basic angle. So before you look for the basic angle, the reference angle, make sure there's no constants in front. There's no constants. Okay, so there's no constant, we can straight away find our basic angle. The first step, our basic angle would be sine inverse, ignore the negative sign, 0.1124. So shift sign 0.1124 will give you 6.45 degree. Okay, so this is the first step. Second step is to sketch out the quadrant. The quadrant, since it's sine negative, that means we are going to choose not this and not this, because quadrant 1 and quadrant 2 is going to be the region where sine is positive, but right now we want sine to be negative, so we are going to choose quadrant 3 and quadrant 4. That's where sine is negative. Okay, so quadrant 3 and quadrant 4. Six point four five. New range. So the new range for this question is, because the range given by the question is 0 to 260, but right now we're looking for not x, we're looking for x minus 80. So we need to look for the range where it's x minus 80. So this is the initial range given by question. If we minus 80, then we will get this. 360 minus 80, you will get 280. Okay, so fourth step, look for the answer. X minus 80 degree equals to the first one, which is this, from here to here. We know that a straight line, this one will be 180 degree, and further extend by 6.45. So this will be 180 plus 6.45. Okay, but be careful with the domain, the range given by the question. This is 280. So if you were to go here, it already exceeded the range, because we know that this is already 90 plus 90 plus 90, which is 270. If you further go here, it will be more than 280 for sure, because if you can find a value, this is 360 minus 6.45, so that's like 355 something. So it already exceeded the range given. So we can't choose this as our solution. We can't choose this as a solution. So we can also go in the negative direction, which is clockwise, because right now the range given is negative 80 degree to 280 degree. So we can also go to the clockwise direction, because to look for the solutions, right, we usually go here, we consider this as the positive, and this is the negative angle. But the range given is from negative 80 degrees, so we can also go in this way, which is negative 6.45 degree, negative 6.45 degree. And can we go to here? No, because this is already 90. So if you were to go at least more than 90, but we are only allowed to go not more than negative 80, not less than negative 80. So it's not allowed to get this, which is negative 180 minus 6.45. So it's exceeded the range already. So this is our answer. So find x. So we're going to plus 80 for both. So 180 plus 6.45 plus 80. So you should get 266.5 degree. And negative 6.45 plus 80. That's 73.55. Okay, let's just arrange in ascending order. 73. I'll just round off. Okay. So this is the solution for this question. So this is the value of x that is within the required domain, the required range given. Okay, so let's look at another one. This one is a little bit advanced. The question that we're going to solve will require knowledge from using basic identities and also your double angle formula. So you have to be familiar, not just memorizing the basic identities like the sine square x plus cos square x equals 1 and things like you can't just memorize. You need to get familiar, meaning that you have to be sensitive towards like, oh, if it's cos square x, it could be written as 1 minus sine square x. So you have to be very flexible with the trigo identities, where like they will be switching around, like they will express cos square x, then you must know this is 1 minus sine square, and if it's sine square x, then you must know immediately this is 1 minus cos square, because sometimes it's like you when you're not familiar with the trigo identity, then it's very hard for you to solve the question in a more simple way lah. Okay, I mean, you can just solve, you can still solve even if you're not familiar, just that it takes more time for you to figure out. You need to list out the formulas, and you need to like switch things around and arrange it, so you take a bit of time. So I would say take more time for you to like practice on proving trigonometric identity. So that's where you practice on how you get more advanced in solving question. I mean, solving in more effective way, more faster, more simple. In the end, you're just trying to solve the equation to find a solution, because proving in SDPM is not as important as I just said before this. So let's look at example 1.64. So find all the angles from 0 degree to 360 degree that satisfy the equation 2 secant square x plus tangent square x equals to 2 secant x. So they want the range from 0 to 360. Always be careful with the range given by the question, because that's where they want the solutions to be. Okay, so what we're going to do is, if you can notice this pattern, right, when secant squared and tangent squared appeared in the same equation, usually we are going to apply this identity 1 plus secant squared 1 plus tangent squared x equals to secant square x. We will somehow use this. So you see, everything is in terms of secant squared and tangent squared now, but there's only one tangent squared, which means we can just get rid of tangent squared and substitute it with our secant squared. How? So with this, tangent square x will be equals to secant square x minus 1, because there's so many terms there. There's like secant, there's like tangent. In solving, we'll try to always make the whole equation with just one single trigo, if possible. Okay, if possible. If it's not possible, then we'll always try to make things easy, like make everything in terms of sine and cos. For example, secant can be written as 1 over cos. Tangent can be written as sine x over cos x according to definition. Cot x can be written as cos x over sine x, which is the reciprocal of tangent x. So we always try to make things simple, because cos and sine will be always easier for us to simplify things. Okay, sometimes when you do halfway and you can cancel out the terms halfway there. So yeah, but in this case we're not going to change things into sine and cos, because I see that tangent squared can be replaced by using this identity. So everything is in terms of secant now, which is more simple, because there's just one term for us to solve it, which is more easy. So let's try to substitute it with this identity. So 2 secant square x, I'm not going to do anything to this, plus tangent square. Okay, tangent square can be replaced by substituting secant square x minus 1 equals to 2 secant x. 2 secant x plus secant square x, 2 secant square plus secant square x, that is 3 secant square x. And I'll move the 2 secant x to the left hand side, which gives us 2 secant x minus 1 equals 0. So if you notice this pattern, this is like 3x squared minus 2 minus 1 minus 2x minus 1. Okay, the pattern is just like x is equals to secant x. I mean, it's more like in the quadratic pattern. It's in the quadratic pattern, so we can further factorize into this, which is 3 secant x plus 1 and secant x minus 1 equals to 0. So 3 secant x plus 1 equals to 0, or secant x minus 1 is equals to 0. So express secant x as a subject. Secant x is equals to negative 1/3. Secant x equals to 1. And you know that secant x means 1 over cos x. Okay, secant x means 1 over cos x. It's the reciprocal of a cos x, the reciprocal of the cos function. So flip it, so we should get this. Okay, I just flip things over. Okay, let's look at this. Is this possible? Is this possible? We know that for a basic cos function, right? I'll just sketch it from 0 to 360. Yeah. The amplitude is 1 and negative 1. The amplitude is 1. It's impossible for the cosine function to have amplitude of negative 3. It's already exceeded the the range of the function. The range is only in between 1 and -1. There's no -3. -3 is like here. There's no graph at all. There's no graph that is like beyond -1 also. So obviously it's not possible. So which means there's no solution for cos x equals -3. So the answer, there's no solution. No, I mean it's not possible. It's not possible. Okay, so not possible. Cos x equals 1. Then there's value for this. There's solution for this. Cos x equals 1. So you see, when cos x equals 1, it will be at, this is 1. It's at 0 and also 360. So x is equals to 0 and 360. So this is the value of x for cos x equals 1. Okay, it can be just obtained from the graph of the cos x. So you don't have to do the 4 steps that I just mentioned before this, because the 4 step usually for values that are like very hard for us to see. For example, like 1/2. I mean 1/2 still okay. For example, like very funny number like 0.1124, 0.4630. These are the value that we don't know how to see from the graph. Okay, we don't know the answer. But for 1 is easy. For 1, for 0, for 1/2, and a few value that I asked you to memorize last week, like sec3/2 and 1/sec2. All these are like simple value, because this is where this is cos 30, and this is cos 45. These are the value that I asked you to memorize. So these are the very common value they will use. But if they don't use it, then you have to use your calculator to find out what is the reference angle. But in this case, we don't have to, because this is cos x equals to 1. Okay, so it's simple. We can just directly see from the graph. We don't need to do the 4 steps for this. So this is a solution for the question. It's very simple. Okay, so we need to identify the quadratic pattern in it. Okay, first we always try to get rid of as much term as possible, meaning that try to make everything, the whole equation, in terms of one trigo, if possible. If it's not possible, we'll try to solve it and see whether we can apply any formula like double angle or basic identity, compound angle. So it depends on the case. If you still can't solve in the end, try to make everything in terms of sine and cos, and then while you are simplifying things, some terms will be cancelled out sometimes. Okay, usually it will be easier for you to solve in terms of sine and cos, as I mentioned last week already, when you're proving your trigo. Okay, and let's look at another example. Example 1.65. Solve the equation 2 cos 2x minus cos x minus 1 equals 0 for 0 to 360 also. So 2 cos 2x minus cos x minus 1 equals 0. So we can see everything's in terms of cos right now. So it's very simple. But notice that this is cos 2x. It's not in terms of cos x, meaning that we need to further simplify. We need to further decompose the formula. Cos 2x, there's 3 formulas for it. First formula is cos square x minus sine square x. Second formula, 2 cos square x minus 1. Third one, 1 minus 2 sine square x. Okay, how do we get these two? We substitute the identity here, the Pythagorean identity. Cos square x is equals to 1 minus sine square x. So this will give you 1 minus 2 sine square x. Sine square x equals to 1 minus cos square x. So this will simplify and give you 2 cos square x minus 1. So this is how we get the third and second formula, by using the Pythagorean identity, the most basic, the sine square x plus cos square x equals 1, that one, and we substitute in here. Okay, so in this case, right, we are trying to make everything in terms of just one trigo. So don't make the whole thing hard, don't make the equation hard by choosing this or this, because there's sine, but everything is in terms of cos right now. So we're just going to choose this. It's more easier for us to simplify things because it's in terms of just one trigo. So for the cos 2x, I'm going to substitute it with 2. Cos 2x, substitute it with 2 cos square x minus 1 minus cos x minus 1 equals to 0. Okay, you expand it, you will get and simplify. So minus 2 minus 1 minus 3. And notice that this is another quadratic pattern. It's almost like 4x squared minus x minus 3, right? So we can further factorize into 2 linear factors, just like how we did just now. So factorize. You should get 4 cos x plus 3 and cos x minus 1. So it's either cos x equals to negative 3/4, we give you 0, or cos x equals 1, give you 0. So we're going to find out using the 4 step, because for this is a very funny value, it's negative 3/4. We're going to use the 4 steps. First step is basic angle. Basic angle, just cos inverse, ignore the negative sign, 3/4. So this will give you 3/4, 41.41. 41.41. Second step, sketch out the quadrant. Okay, sketch out the quadrant. So since this is cos negative, you are going to choose this and this, which is the reference angle will be here. Okay, this is second step. Third step, new range. So we don't need a new range for this because it's in terms of x, right? So we just follow this because it's x, and this is also x, so don't need to choose new range. So the range will follow exactly like the question, from 0 to 360. Okay, last one, solve. So x is equals to first one, 180 minus of this region, 41.41. 180 minus 41.41. Another one is 180 plus 41.41. So what's this? 180 minus 41.41, 138.59. I just round off the value. 180 plus 41.41, 221.4 degree. So this is the solution for cos x equals negative 3/4. And when cos x equals 1, this is simple, we just did just now, which is 0 and 360. So the answer, 0 and 360. Very simple, just sketch out the graph and determine where is the x value when cos x equals 1, which is 0 and 360 degree. So the final answer, we need to take all. We take all means 0, 138.6. We're going to arrange in ascending order lah. 221.4 and 360. So this is the answer.